Dear students, in our last class we were discussing the introductory part of ray optics, in which we were discussing what it means by optics, what is the ray of light, what is the beam of light, and about the mirror, the types of mirror, so which were plane mirror and spherical mirror. And in spherical, so we have studied what is a concave mirror and what is convex mirror. And also we discussed some important terms related to the spherical mirrors. After that, we were discussing the Cartesian sign convention and the general rules to draw the ray diagram, and we discussed the formation of image with respect to the formation of object. Okay, so today we will discuss the further part of that ray optics. Okay, today we will start with the concept laws of reflection. Laws of reflection. Okay, there are two laws, or in some book they have written it as rules of reflection. First law and second law. So in the first law, the incident ray, reflected ray, and the normal drawn at the point of incidence. For example, this is a mirror. This is a mirror. Okay, and a ray of light is incidenting on the mirror. This is incident ray. And I draw a normal line. At the point of incidence. Okay, and this will be the reflected ray. Okay, so idu incident ray, idu reflected ray, idu normal line ಅಂದ್ರೆ ಎಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರ್ತದನೋ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಸರ್ಫೇಸ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಒಂದು ಲೈನ್ ಡ್ರಾ ಮಾಡ್ತೇವೆ. ಸರ್ಫೇಸ್ ಗೆ ನಾರ್ಮಲ್ ಆಗಿ ಲೈನ್ ಡ್ರಾ ಮಾಡ್ತೇವೆ. ಸೊ ದಟ್ಸ್ ವಾಟ್ ಇಸ್ ನಾರ್ಮಲ್ ಲೈನ್. ಇನ್ಸಿಡೆಂಟ್ ರೇ, ನಾರ್ಮಲ್ ಲೈನ್ and reflected ray. Okay, so all these three are in same plane. This is our first law. So what's the first law? The incident ray, reflected ray, and the normal drawn at the point of incidence all lie in the same plane. So this is first rule, very simple. And the second law about the incident angle and reflected angle of incidence and angle of reflection. Okay, what's the angle of incidence? See, the angle made by the incident ray. The angle made by the incident ray with the normal line. This is called angle of incidence. Okay, and the angle made by reflected ray. Angle made by reflected ray with the normal. So this is called angle of reflection. This is angle of incidence and this is angle of reflection. Right? Okay. So what's the second law? As per the second law, the angle of incidence is always equal to angle of reflection. Angle of incidence is always equal to angle of reflection. So these are the two important laws related to the reflection. Okay. Next point is the relation between focal length and radius of curvature. Its symbol is small f and this is capital R. What's the focal length? The distance of the principal focus from the pole. Okay, so this is the concave mirror and this is the pole. And this is principal focus. It is indicated by capital F. And this is the center of curvature C. And for this distance, we call the focal length. We call this as focal length. And the distance of the C from the pole, this is called R, means radius of curvature. Okay, so we should establish the relation between F and R. Okay, see the diagram. So a ray is incidenting on the concave mirror. This is incident ray. And at the point of incidence, I draw a normal line. And if you draw a normal line from any point of the mirror, it must passes through the C. Okay. So whenever there is parallel incidence, so there will be a reflection. That reflected ray passing through the principal focus like this. Okay, incident ray, reflected ray, and the normal at a point of incidence. Is it clear? Okay. Then for this angle, what do you call for this angle? Angle of incidence, and symbol is I. Okay. Then what is this angle? So this is angle of reflection. And as per the first law, angle of incident and angle of reflection both are equal. I say they are of theta, and this is also theta. Okay. So explanation in derivative now. First no delay, and I say this is A and N, this is B. ಏನಾಗ್ತದ ಒಂದು ಕಾಂಕೇವ್ ಮಿರರ್ ಅದ. ಈ ಕಾಂಕೇವ್ ಮಿರರ್ ಮೇಲೆ AN ಇನ್ಸಿಡೆಂಟ್ ರೇ, ಲೈಟ್ ರೇ ಫಾರ್ಮಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ಲತ್ತದ. ಇಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿದ್ದು ಈ ಕಡೆ ಹಿಂಗೆ ರಿಫ್ಲೆಕ್ಟ್ ಆಗ್ಲತ್ತದ. ಸೊ AN is incident ray, BN is reflected ray, and what is the CN? It is normal line. Okay, ಅದೇ ಎಕ್ಸ್ಪ್ಲೇಷನ್ ನಾವಿಲ್ಲಿ ಬರಿಬೇಕಾ. What is AN? AN equal to incident ray. Okay, incident ray, BN is reflected ray, CN is normal line. And what is the distance PF? So this is focal length, and symbol is F. And see what should be the sign, positive or negative. First at the sign convention, our measurement is in the direction opposite to the incident ray, so that's why this distance is negative. Okay. And PC, the distance from P to C. So what do you call for this one? This is radius of curvature. Radius of curvature. Its symbol is R. And this is also negative. Okay, this is sign convention. And say, as per the law of reflection, angle of incidence equal to angle of reflection. Angle of incidence equal to angle of reflection. Okay, so what's the name of incident angle here? So from ANC, so it's the angle of incidence ANC, and what's the angle of reflection? CNB. This angle CNB. So CNB, and both are of the same value, that is theta. Okay, then now consider, okay, if this angle is theta, so which one? ANC is theta. Then what about this angle? If this is theta, then this is also theta. Okay, so it is like this. So if this is theta, this must be theta. Is it? So this is A, N, and this is C. And one more. Can you estimate this angle? Right? Okay. So this is theta and this is theta. What's the angle between the incident ray and reflected ray? From incident to normal line, theta. From normal to reflected ray, one more theta. So totally this is 2 theta. So this angle is also 2 theta. Okay. So like this. If this is 2 theta, then this is also 2 theta. Right? So now I can write these values. If okay, ANC is equal to, we can write that value, angle ANC equal to NCF equal to theta. Is it? In the same way, angle ANF, this is 2 theta. ANF equal to NFP. This is 2 theta. Is it clear? Okay. So then I will draw one more line here. I will draw a perpendicular line from the point of incidence to the principal axis. It meets somewhere here. Okay, and I call this point as D. This is D point. This is pole P. Clear? Now consider the triangle. Now consider the triangle CND. The triangle CND. Okay, is it right angle triangle or not? C to N and D. This dotted line. So it is like this. CND. Is it? And what's the angle at C? This is theta. Okay, so from triangle CND, I can write the value of tan theta is equal to. So what's the formula for tan? Opposite side divided by adjacent side. So what's the opposite side here? ND. And what's the adjacent side? This is CD. Okay, but here the theta is very small. Theta is very small, such that we cannot apply the tan function. Illen theta form agidalla, idu baa kadime angle irtada. So iva ನಾವು tan ಅಥವಾ ಯಾವುದೇ ಟ್ಯಾನ್ ಫಂಕ್ಷನ್ ಅಪ್ಲೈ ಮಾಡೋದು ಬಹಳ ಡಿಫಿಕಲ್ಟ್ ಆಗ್ತದೆ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಇಲ್ಲಿ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂತೇವ, ದ tan theta is taken to be only theta. So now the theta is equal to ND divided by CD. Say equation number 1. Right? What we did here? We have taken the triangle CND. Okay, in that tan theta is equal to ND divided by CD. Okay, opposite side divided by adjacent side. And theta was very small, so I have taken only theta instead of tan theta. Okay, the next point. Similarly, we can take one more right angle triangle. From the right angle triangle NFD. Okay, so here from NFD, this right angle triangle. Okay, and here it is 2 theta. Again, I want to write the tan equation here. Tan value. Tan of it's not a theta. Now the angle length is 2 theta. The value of angle is 2 theta. So that's why it is tan of 2 theta is equal to opposite side divided by adjacent side. Opposite is ND and adjacent side FD. This is opposite ND and this is adjacent FD. Okay, so again for very small theta, again we will write only theta. That is only the angle, but it is not a theta. This is 2 theta. Okay, or you can write for a small angle. Right? For a small angle, 2 theta. So we remove the tan function. We have written only 2 theta is equal to ND divided by FD. So equation number 2 is equation number 2. Okay. Observe the equation 1 and equation 2. So what was the equation 1? In equation 1 you are having the value of theta, and in equation 2 this is 2 theta. Howda? So first only theta value ada, secondly 2 theta ada. Now you can substitute the value of theta in equation 2. Equation 2 nalli theta value na substitute ಮಾಡಬೇಕಾ? ಹೇಗೆ? 2 as it is ಇಟ್ರಿ, theta ಬದಲಾಗಿ ND by CD substitute ಮಾಡೋದು. Next, ND divided by FD as it is. So, ಇಲ್ಲಿ ನಾನು ಬರೀದಿನ substitute value of theta in equation 2. From where you can take the value of theta? From equation 1. So, equation 1 ನಲ್ಲಿರೋ theta ನ 2 ನಲ್ಲಿ substitute ಮಾಡಿದ್ವಾ? So, ಏನಾಗ್ತದ? 2 as it is. Instead of theta, I will write ND by into the next ND divided by CD. Okay, equal sign, and it is as it is ND by FD. ND divided by FD. Okay, now here the numerator is ND and RHS side, this is also ND. We can cancel this one. ND cancels. And the next step is here ND cancel. So 2 into 1 by CD, 2 into 1 by CD equal to 1 by FD. ND cancel. 1 divided by FD. Okay, and see that diagram. The D and P, they are very close to each other. D and P are very close to each other, and we can say the distance from C to D is nearly equal to the distance from C to P. Okay, ಈ D and draw ಆಗಿದೆ, ಇಲ್ಲಿನ perpendicular line ಗೆ draw ಮಾಡಿದ್ವಿ. So ಈ distance ಬಹಳ ಕಡಿಮೆ ಇರ್ತದ. For example, radius of curvature 30 cm ಇರ್ತಾ. 30 cm ಇರ್ತಾ. Okay, P ದಿಂದ D ಇದು 0.1 cm ಇರ್ತದ. So ಆಗ 30 cm ಅನ್ನೋ ಬದಲಿ 29.9 cm. So both are same. Okay, so ಅದಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಅಲ್ಲಿ, the distance or the point P is very close to D. P is very close to D. Therefore, instead of writing CD, I can write CP. Instead of writing FD, I can write FP. CD ಬದಲಿ CP, FD ಬದಲಿ FP. ಆಮೇಲೆ ಆ ವ್ಯಾಲ್ಯೂ ಬರ್ಬಿಡೋಣ ಇಲ್ಲಿ. So CD, instead of CD, I will write CP, and this is 1 divided by FP. Okay, and the cross multiplication 2 FP is equal to CP. 2 FP equal to CP. And say this one. So FP means focal length. F to P, this is focal length. Okay, 2 into. But focal length, as per sign convention, now it is negative. FP. And what is the CP? CP. P ದಿಂದ C ವರೆಗೂ distance. This is the radius of curvature. That is also negative, minus R. And here also negative, here also negative. So we can remove the negative signs. 2F is equal to R. 2F equal to R. This is the relation between the focal length and radius of curvature. Right? Or we can write F is equal to R by 2. F equal to R by 2. So this is a small derivation, so which is oftenly asked in your exam. Okay. The next point is the mirror formula, in which we are going to derive the relation between focal length, object distance, and image distance, and the respective symbols F focal length, U object distance, and V image distance. Okay, now these are the two new symbols, U and V. U is object distance and V is image distance. What's the object distance? Very simple. The distance of the object from the pole of the mirror. ಯಾವ ವಸ್ತುದ ಇಮೇಜ್ ನೋಡ್ಬೇಕು ಅನ್ಸಿತ್ತದಲ್ಲ, ಆ ವಸ್ತು ನೀವು ಹಿಡಿತೀರಿ ಯಾವುದೋ ಒಂದು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ. ಮಿರರ್ ಪೋಲ್ ದಿಂದ ಆ ವಸ್ತು ಎಷ್ಟು ದೂರದಲ್ಲದ, ಅದು ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್. Okay, as a result of reflection, there will be the formation of image. ಯಾವುದೋ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು ಮಿರರ್ ಮುಂದೆ ಚಾಕ್ಪೀಸ್ ಇಟ್ಟ ತಕ್ಷಣ ಈ ಚಾಕ್ಪೀಸ್ ಮಿರರ್ ಎಷ್ಟು ದೂರದಲ್ಲದ, ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್. And you can get the one more picture of the chalk piece, so which is called as image. And what is distance from the pole? That is image distance. Is it? Okay. And see the ray diagram. Here the AB indicating the object. Okay. So from the AB, so see here the rays of light are incidenting on object from the source. As a result, it is giving reflection. And some of these rays are incidenting on the mirror and the image is forming. Now I take only 2 rays. So why should take the 2 rays? So to give the representation of formation of image, there must be at least 2 rays, 2 reflected rays. So that's why I am taking 2 incident rays. As a result, there will be 2 reflected rays. Okay, this is the object. AB object is AB dinda in line inge incident agala. Ray of light point P nalli incident aita. Okay, so ನಮಗೆ ಗೊತ್ತು ಯಾವ ಆಂಗಲ್ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರ್ತದನೋ ಅಷ್ಟೇ ಆಂಗಲ್ ಅಲ್ಲಿ ಏನಾಗ್ತದ ರಿಫ್ಲೆಕ್ಷನ್ ಆಗ್ತದ. ಸೊ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆಂಗಲ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಷನ್. ಓಕೆ, ದ ಇನ್ಸಿಡೆಂಟ್ ರೇಸ್ AP from A to P and P to B. This is P to something. Okay, from here to here this is reflected ray, right? AP is object and see illinda ray hoytu ಇಲ್ಲಿ reflect ಆಯ್ತಾ. And there is one more ray. Actually there are so many rays. For our study, for simplification, I am taking only 2 rays. Okay, so ಇನ್ನೊಂದು ray ಏನಾಗ್ಲತ್ತದ C ನಲ್ಲಿ ಪಾಸ್ ಆಯ್ತು, ಮಿರರ್ ಅಲ್ಲಿ ಬಿತ್ತು. ಯಾವುದೇ ray C ನಲ್ಲಿ ಪಾಸ್ ಆಗಿಬಿಟ್ಟು ಇನ್ಸಿಡೆಂಟ್ ಆಗಿತ್ತಂದ್ರೆ ಅದೇನಾಗತ್ತಾ ಅದರದ ಒರಿಜಿನಲ್ ಪಾತ್ ಅಲ್ಲಿ ಅದು ವಾಪಸ್ ಆಗತ್ತಾ. ಸೊ ಇಫ್ ದ ಇನ್ಸಿಡೆಂಟ್ ರೇ ಇಸ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಸಿ, ಇಟ್ retraces its path. So this is the incident ray and this is the reflected ray, right? So both are in the same path. So that's why I have done only one path, and the symbolic I am giving 2 arrow marks. So one is for incident and one is for reflection. Is it? Okay, and see, is one reflected ray and so one more reflected ray. So they are meeting at this point. So that's why the image forms here, right? So the clear picture: AB object, A dash B dash image, incident ray, reflected ray, incident ray, reflected ray. Is it clear? So we should explain the same thing here. We should explain the same thing like what is PF. So now I don't write the incident ray and reflected ray. Directly I go for the important points. Now PF. PF focal length from here to here, and the symbol is F. Again, by the sign convention, I will write negative. And what's the PC? From P to C. What's the distance? It is radius of curvature. Its symbol is R, and its symbol is it's a sign minus R because of the Cartesian sign convention. You know this. Okay. What is the PB? So from P to B distance. So in P there is an object. At B position there is object, so that's why from P to B we call the object distance. We call it as object distance. Okay, and the symbol is U, also negative. Why the negative? The direction of our measurement from P to 1, 2, 3, 4, 5 like this we may measure up to B, and the direction of measurement is opposite to the incident ray. The direction of incident is our direction of measurement. So that's why this is also negative. And what's the PP dash? At B dash position, so there is a formation of image. That's why we call it as image distance. We call it as image distance. And its symbol. Its symbol is V. And the negative sign, because this is also in the direction. This measurement is also from P to B dash is also in the direction opposite to the incident ray. Okay, so minus R, minus U, minus U. ಗೊತ್ತಾಗ್ತದಲ್ಲ, ಈ ಡಯಾಗ್ರಾಮ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಇನ್ ಫಸ್ಟ್ ನೋಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ದೆನ್ ಕನ್ಸಿಡರ್ ಟ್ರಯಾಂಗಲ್ A B C and triangle A dash B dash C. So where is ABC triangle? A B C. And where is A dash B dash C? A dash B dash C. Okay, I will draw one more time here. So just for your understanding purpose, this is the triangle. These are the triangles, and this is B dash. Okay. Observe these 2 triangles. So what's the conclusion? We say these are similar triangles. These are similar triangles, not a same triangle. If you want to say same triangle, there must be all sides are equal and all corresponding angles of those 2 triangles are equal. But in similar triangle, all three angles of a triangle are equal to corresponding angles of another triangle. ಏನಾಗ್ತದೆ ಇದು 90 degree ಇದೆ. See here, this is 90 and this is also 90. One pair of the angles, and this angle and this angle. See here, this angle and this right angle triangle. If the 2 angles are equal, then the third are also equal. So that's why we say A, B, C and A dash, B dash, C. So these 2 triangles are similar. Okay, and we know for the similar triangles, the ratio of corresponding sides are always equal. The ratio of corresponding sides of similar triangles are always equal. For example, the opposite side of one triangle divided by opposite side of another triangle, it gives some value, I say x. Okay, and if I take adjacent side of one triangle divided by adjacent side of another triangle, again you will get x. Hypotenuse side of one triangle divided by hypotenuse side of another triangle, again you will get x only. So this is the significance of the similar triangles. If you take the ratio of same sides, respective sides, there will be equal value. Okay, if so, a dash divided by b dash, this side, opposite side of this small triangle, divided by, ಈಗ ಯಾವ ಸೈಡ್ ತಗೋಬೇಕು ನಾನಿಲ್ಲಿ, ಇದು ಯಾವ ಸೈಡ್ ಅದ ಅಲ್ಲಿ ಸೇಮ್ ತಗೋಬೇಕಾ, right? Okay, so this is opposite side and this is also opposite. I'll write AB, a dash b dash divided by AB, and I'll take the adjacent side ratio. This one, b dash c is adjacent side of this triangle, b dash c, and this is the adjacent side of another triangle, BC. So I'll write b dash c divided by BC. Okay, say equation number 1. Say equation 1. In the same way, consider one more pair. Consider triangle A P B. See this one, or you can write ABP. A B P and triangle A dash B dash P. Where is the APB? ABP A. This is B, and see this one, A P B. This is one triangle, and second one A dash B dash P, A dash B dash P. This triangle. Okay, I'll write roughly this one. Okay, this is A, this is B, and this is B dash, this is A dash, this is P. I'm talking about these triangles. See, are they similar triangle or not? We'll check. One angle is 90 degree, and another angle, one angle in another triangle is also 90, and these two angles are equal. Why these two has to be equal? This is incident ray, this is reflected ray. Incident ray, reflected ray, and this is a normal line. Incident ray equal to incident angle equal to reflected angle. So here, this angle and this angle are equal. Then this angle and this angle are equal. So two pair of those two triangles are equal. So that's why those two are similar triangle. Similar triangles. Is it? Okay, and next again check the ratio. A dash B dash divided by AB. What about A dash B dash? A dash B dash, opposite side AB. Okay, and then adjacent side B dash P divided by BP. This one. So this is the adjacent side of this triangle. This is the adjacent side of this large triangle. Okay, I'll write. So this is P B dash divided by PB. Where is P B dash? Here to here. This is the adjacent side of this triangle. Adjacent side of this triangle. And there is one more large triangle. This BP or PB. PB dash divided by PB. So I say this equation number 2. Is it? Observe equation 1. That equation 1. And this equation 2. Equation 1 and equation 2. The LHS of these two are same. So that's why their RHS are same. Okay, I equated it. Is it A dash B dash by AB? And here also A dash B dash by AB. And this value or this ratio must be equal to this one. Okay, I'll continue this. Now, this B dash C divided by BC is equal to PB dash divided by PB. PB dash by PB. Okay. B dash C. Where is B dash C? B dash C and BC. So we should write all these values. We should write all these 4 values in terms of our noun terms. So we have only 4 terms: F, R, U, V. We should mention everything in terms of U, V, F and R only. Okay, so that's why I want to write the B dash C and BC in terms of these noun values. Okay, how to write? Let's say B dash C is this distance, B dash C. Okay, but I know the distance from P to C. Here to here, this is PC. Here to here, this is PC. So, ಈ PC ನಲ್ಲಿ ನಾನು ಇವಾಗ PB dash ಕಟ್ ಮಾಡಿದ. ಟೋಟಲ್ ಇದು PC ಇಲ್ಲಿವರೆಗೂ. ಇದು PB dash ಕಟ್ ಮಾಡಿದ. ಏನು ಉಳಿತದ? ಇಷ್ಟು ಉಳಿತದಲ್ಲ ವ್ಯಾಲ್ಯೂ. ಓಕೆ, ಸೊ ಅದಕ್ಕೆ ನಾನು CB dash ಅಥವಾ B dash C. ಈ B dash C ಬದಲಾಗಿ ಏನು ಬರೀತೇನಾ? ಟೋಟಲ್ ಐ ಟೇಕ್ ಫಸ್ಟ್ PC. ಓಕೆ, ಈ PC ನಲ್ಲಿ ಏನು ಮಾಡೋಣ ಇವಾಗ? PB dash ಕಟ್ ಮಾಡಿಬಿಡೋಣ. PB dash minus PB dash. Is it clear? PC ನಲ್ಲಿ PB dash ತೆಗೆದು ಬಿಟ್ವಿ. ನಮ್ಗೆ ಬೇಕಾಗಿರೋ ವ್ಯಾಲ್ಯೂ ಉಳಿತಲ್ಲ B dash C ಅಂತ. ಸರಿ, ಡಿವೈಡೆಡ್ ಬೈ ಇನ್ನೊಂದು ಟರ್ಮ್ ಡಿನಾಮಿನೇಟರ್ ಇರೋದು BC. ಈ ವ್ಯಾಲ್ಯೂ ನಮಗೆ ಕೊಟ್ಟಿರೋ ವ್ಯಾಲ್ಯೂ BC ಈಕ್ವಲ್ ಟು ಏನಂತ ಗೊತ್ತಿಲ್ಲ. ಓಕೆ, ನಾವು ಹಿಯರ್ BC. ಇವಾಗ P ದಿಂದ B ವರೆಗೂ ಡಿಸ್ಟೆನ್ಸ್ ತಗೊಳ್ಳಿ. ಎಷ್ಟರ ವ್ಯಾಲ್ಯೂ? P ದಿಂದ B. ಇದು ನಮ್ಮ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತದ. ಎಲ್ಲಿ ಬರ್ತದೆ? BB ಇಸ್ ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್. ಓಕೆ, ಈ PB ನಲ್ಲಿ PC ನ ಮೈನಸ್ ಮಾಡಿಬಿಟ್ಟ, ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ. ಟೋಟಲ್ PB ಇದು PC ತೆಗೆದ್ಬಿಟ್ವಿ. ನಮ್ಗೆ ಬೇಕಾಗಿರೋ ವ್ಯಾಲ್ಯೂ ಉಳಿತಲ್ಲ ಇಲ್ಲಿ ಏನು? BC. Is it? Okay, so how to write the BC now? First take PB minus ಈ PB ನಲ್ಲಿ ಏನು ಮಾಡಿ ಇವಾಗ PC ಕಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ವಾ, minus PC. Is it? Okay, and the RHS are as it is PB dash divided by PB. Okay, so you know the value of PC, you know the value of PB, you know the value of PB dash, and substitute these values. PC equal to minus R, radius of curvature, and this minus as it is, and PB dash. PB dash, where is the PB dash? See here, PB dash is the image distance. So write minus B divided by PB. P to B was the PB. Here the object distance, and this is also negative minus U. And this minus as it is PC. Again minus R. Equal to what is PB dash? B dash means is the position of image. PB dash means image distance. This minus U. PB, P to B, where the object. So this is object distance minus U. This is V and this is U. Minus cancel. Okay, then minus R, minus of minus plus V divided by minus U, minus of minus plus R equal to V divided by U. V divided by U. And take a cross multiplication. Minus RU plus UV. I multiplied this U here, so U multiplied with the R, this become RU with the negative sign, and U multiplied with the V, this become UV. Okay, equal to, take this denominator right hand side, multiply this U with the V, this become minus UV and plus RV. Is it clear? And this is equal sign. Okay, and then rearrange the terms. Once again, minus RU plus UV equal to minus UV plus RV. So rearrange the terms so that you can get only the positive terms. ಓಕೆ, ಏನ್ ಮಾಡ್ರಿ ಇವಾಗ ಈ ಕಡೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಈ ಕಡೆ ಕಳಿಸ್ರಿ, ಅದು ಪಾಸಿಟಿವ್ ಆಗುತ್ತಾ. ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಈ ಕಡೆ ತಗೊಂಡ್ ಬನ್ನಿ, ಅದು ಪಾಸಿಟಿವ್ ಆಗ್ತದೆ. ಸೊ ಇವಾಗ ಈ ಸೈನ್ ಅನ್ನು, ಈ UV ನ ಈ ಕಡೆ ತಗೊಂಬಂದ ಪ್ಲಸ್ UV, and already there is a UV equal sign. Take this RU this side, this become plus RU, and one RV is there. Clear? Right. So UV plus UV, 2 UV equal to 2 UV equal to RU plus RV. right? I call this equation number 3, or let's say UV. Okay, see what's our intention? We have to derive the relation between F, U, V. And see the last equation, we are having the U term, we are having the V term and R. So only thing is, we should introduce the F term. Focal length term only introduce ಮಾಡಬೇಕಾ ಈ equation ನಮಗೆ ರಿಲೇಷನ್ ಇದೆ UV ರಿಲೇಷನ್ R ಜೊತೆ ಬಂದದ ಇವಾಗ UV ರಿಲೇಷನ್ ಅನ್ನ F ಜೊತೆ ಮಾಡಬೇಕಾ ಸೊ ಅದಕ್ಕೆ ಮಾಡೋಣ ಸೊ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಬಾಕಿ ಇದೆ ಓಕೆ ಸೊ ಇವಾಗ ಏನಂತ ಹೇಳ್ತೇನೆ ನೆಕ್ಸ್ಟ್ divide the equation it means this equation by R U V. Divide the equation by R U V on both sides. Divide the equation by R U V on both sides. ಈ equation ಗೆ divide by R U V ಮಾಡಬೇಕಾ ಏನಾಗ್ತದ right. This equation 2UV divided by, as per this one, RUV equal to, this is RU divided by RUV plus, here it is RV divided by RUV. Okay, and then now this UV and this UV, it can't be like that. Okay, right. Then this UV cancel, and here it is only 2 by R. Next, this RU and this RU cancel. This is 1 divided by V plus sign, and this RV then RV cancel. This is 1 divided by U. Okay, so 2 by R equal to 1 by V plus 1 by U, and we know the relation between R and F, but R equal to 2F. R equal to 2F. Okay, so again I put 2 as it is, instead of R I write 2F equal to 1 by V plus 1 divided by U, right? 2 cancel. Now I can write 1 by F equal to 1 by U plus 1 by V. So this is our final derivation, right? See that last equation, we are having focal length, we are having object distance U, and we are having image distance V. So this is the relation between F, U and V. Or you can simplify this one and you can write UV divided by U plus V. UV divided by U plus V. Okay, so this is mirror formula. Once I'll repeat in 1 minute. So first I'll draw the ray diagram, and this is incident ray and this is reflected ray. So the PF from P to F, it is focal length, PC, radius of curvature, and we know the sign convention. So that's why it is negative. So PB dash image distance, PB is object distance. What we did first? First we have taken the triangle ABC and A dash B dash C, these two triangles, and as per our previous knowledge you can say these are similar triangles. So the ratio of the corresponding sides of the similar triangles are equal. So that's why we have taken the opposite side divided by this opposite side, AB dash by AB. Then adjacent side B dash C of one triangle divided by adjacent side of another triangle BC. Okay, and in the same way, there is one more pair of single triangle, that is ABP. See this one, ABP, and A dash B dash P, the small triangle. These are also similar triangles. So there I have taken the ratio of their corresponding sides. And the next step, the RHS of first equation and RHS of second equation, they are same. So that's why, LHS are same. So that's why their RHS is also same. Next, B dash C of first equation equal to B dash C by BC of first equation equal to PB dash by PB. I write. And I want to write the entire terms in terms of F, R, U, V. So that's why instead of writing b dash c, where is the b dash c? Here, b dash c. I have taken pc minus pb. P to c first minus pb dash. I get this one. Okay. In the same way, bc, from b to c here. So instead of writing bc, I take first pb and I have subtracted the pc. pb and pc. So I write like this. And substitute the value of pc, radius of curvature, pb dash image, pb object, pc radius of curvature, and negative signs are for sign convention. Okay, then pb dash image distance v, pb object distance. Okay, in the next step, minus minus cancel, and minus r plus v. See here. Then minus u plus r. Then cross multiplication, and I simplified for 2ub equal to ru plus rv. See this ru, u, and this is v. Okay. Next, what we did, we want to introduce the focal length. So that's why I divide the entire equation by ruv. So this value divided by ruv, this value divided by ruv, and cancel the terms, and finally we got 1 by f equal to 1 by u plus 1 by v. Okay, we can take the LCM and simplify. It will be uv divided by u plus v. We can note down this one.